We're going to be looking at the discriminant and factoring. So given a quadratic, the question becomes is how do you know whether you can factor it or not? You can actually use the discriminant to help you determine whether you can factor a quadratic. And here's what you need to know. If your discriminant is a perfect square, then that quadratic is actually factorable. So let's take a look here and see why that's the case. Let's take a look at this quadratic here. So this quadratic is obviously factorable. I've factored it right here. All right, it factors into this. It is a factorable quadratic. Let's go ahead and look at the discriminant. What is the discriminant of this quadratic? Well, the discriminant is going to be b squared minus 4ac, in which case we get 169, 120, and the discriminant becomes 289. Well, 289 is a perfect square. Reason for that is this is equal to 17 squared. So if I go ahead and calculate my roots here, what happens? If I go to calculate my roots, the roots are going to be negative b plus or minus the square root of 289 over 2 times a is negative 13 plus or minus 17 over 12. So if you go ahead and calculate this, you're going to get 1/3 and negative 5 over 2. Okay? So notice in this example here, my discriminant was a perfect square. All right, the square root of 289 is 17. Notice here we get rational roots. Okay, let's look at the next example. All right, got another quadratic, x squared minus 4. Clearly it's factorable, but what does the discriminant tell us? Well, my discriminant here is going to be b squared minus 4ac. Your discriminant comes out to be 16, which is a perfect square, right? 4 squared is 16. So if you go ahead and calculate your roots here, it's going to be negative b, which is negative 0, plus or minus the square root of 16 over 2 times 1 is going to be 0, plus or minus 4 over 2 is going to be plus or minus 2, which is the roots that we would have normally get if we factored. But the point being here is, again, I have a quadratic that is factorable, has integer roots, and its discriminant was a perfect square. Okay, let's try another. Same idea here. So my discriminant here is going to be b squared minus 4ac, and the discriminant ends up being 100 minus 96 is 4. Discriminant is 4, which is obviously a perfect square. So again, we have a quadratic that is factorable. Discriminant is a perfect square. And the roots here, in this case, if we go ahead and do the quadratic equation or just solve it here, you get negative b plus or minus the square root of 4 over 2, which is negative 10 plus or minus 2 over 2, which is negative 6 and negative 4, like we had gotten. Okay, so once again, you have a quadratic. It is factorable. Discriminant is a perfect square. Okay, let's take a look at this next example here. Here I have a quadratic, x squared plus x minus 1. It actually has roots at plus or minus negative 1 plus or minus root 5 over 2. So the roots that this quadratic has are irrational. So this has irrational roots. And furthermore, this is not factorable. You can't think of two numbers that multiply to be negative 1 and add to be 1. So what does the discriminant tell us here? Well, the discriminant is going to be b squared minus 4ac. So my discriminant here is going to be 1 plus 4. My discriminant is 5. This is not a perfect square. Okay, let's take a look at what this looks like in the quadratic equation. Well, this is going to be x equals negative 1 plus or minus the square root of 5 over 2. Notice, because my discriminant, which in this case was 5, was not a perfect square, I was unable to cancel off the square root. And because of that, I was left with an irrational root. If you have an irrational root, that means that certainly it can't be factored, because if your quadratic was factored, you'd be left with a rational root or an integer valued root. Okay, let's look at another. Okay, let's look at this one here. This is x squared plus 2x minus 7. Now again, you need to think of this as a simple trinomial. So if this was actually factorable, you need to think of two numbers that multiply to be negative 7 and add to be 2. Instead of wasting your time to try to figure out whether these numbers exist or not, do a quick check on your discriminant. My discriminant here is going to be b squared minus 4ac, in which case I get 4 plus 28. My discriminant comes out to be 32. 32 is not a perfect square. So because it's not a perfect square, I don't need to go searching to see whether my quadratic is factorable or not. I know it's not. In fact, to prove it, I go to calculate my quadratic equation. You get negative 2 plus or minus the root of 32 over 2 times 1. And again, those are my two roots. It does not break down into rational roots or integer roots. So just in conclusion here, the idea here is that if you have a discriminant, in this case b squared minus 4ac, if it is a perfect square, then your quadratic is factorable. You can factor it using charting, decomposition, product sum, difference of squares, all the techniques that we've talked about. And in fact, not only is it factorable, the roots are going to be rational roots. And by rational roots, I mean the roots can be rational values, integer values, etc. If the quadratic is not a perfect square, then that means that the roots that quadratic has are irrational. And to actually find those roots, you'll need to use the quadratic equation. So this is a handy check for yourself. Instead of searching forever to see whether you can factor a quadratic or not, do a quick calculation, b squared minus 4ac. If it's a perfect square, go ahead, use your charting, use your decomposition, use your difference of squares. Okay, hopefully this helps. Thank you.